Let's start now. Number 10. Earth sits in the perfect spot. Earth is not just anywhere in space. It sits inside a very specific region around our Sun called the habitable zone. That is the narrow band where temperatures allow liquid water to exist on a surface for a long time. But Earth does not sit at the edge of that zone. It sits right in the middle, in the safest, most stable position possible. If Earth were just a little closer to the Sun, temperatures would be far too high. Water would boil away into gas. Nothing could survive. If Earth were just a little farther from the Sun, temperatures would drop far below freezing. Oceans would lock into permanent ice. Life would never get a chance to begin. Earth is right in between. Not too hot, not too cold. Most planets have orbits that stretch and wobble, pulling them closer to their star sometimes and pushing them far away at others. Earth is different. Its path around the Sun is nearly a perfect circle. The amount of sunlight Earth receives stays fairly consistent all year long. That consistency matters more than it sounds. Early life is incredibly fragile. If temperatures jumped wildly from one extreme to another, the first tiny living things would never survive long enough to grow and change. Our Sun helps too. It is not too large and not too small. Many stars release violent bursts of radiation that would strip a planet bare. Others burn through their fuel too quickly. Our Sun has been providing calm, steady energy for over 4 billion years. When you combine Earth's perfect distance, its circular orbit, and the steady behavior of our Sun, the result is a system that holds its temperature with extraordinary stability. That stability is rare, and without it, nothing else on this list would matter at all. Number 9. Earth has a suspicious amount of liquid water. Earth does not just have a little water sitting in puddles and rivers. It has vast, deep oceans covering more than 70% of the entire planet's surface. And those oceans have remained liquid for nearly 4 billion years. That is extraordinarily rare. Most rocky planets either lose their water early because their gravity is too weak to hold on to it, or they never reach temperatures warm enough to prevent it from freezing permanently. Earth managed to get both things right, and keep them right, for billions of years. Once the oceans formed, they began acting as a giant temperature regulator. Water heats up slowly and cools down slowly. The oceans absorb heat during warm periods and release it gradually during cold ones. They smooth out temperature extremes like a planetary blanket. That gave early life a calmer home. Instead of a wild, violent environment, the first living things had a relatively stable place to grow and experiment over millions of years. Water also makes chemistry easier. It dissolves minerals and carries them through the environment. It allows complex molecules to move around, meet each other, and interact. The early oceans were like one enormous chemistry laboratory running around the clock for hundreds of millions of years. And here is a detail that often surprises people. When water freezes into ice, that ice floats. It rises to the top instead of sinking. That single physical property is enormously important. Floating ice forms a protective layer on the surface of cold water. It insulates the liquid water below and keeps it from freezing all the way through. If ice sank instead of floating, oceans would freeze from the bottom up. All liquid water would disappear. Life would have had nowhere to survive. Water does not just support life, it actively protects it. Number 8. Earth's atmosphere functions like a life support system. Think of Earth's atmosphere as a protective system doing several jobs at the same time. First, it acts as a shield. When rocks from space come flying toward Earth at tremendous speed, most of them burn up inside the upper atmosphere before they ever reach the ground. Without this protection, the surface would be bombarded constantly by impacts large enough to wipe out entire ecosystems. The atmosphere also filters out ultraviolet radiation. That is a form of invisible energy from the sun that causes deep damage to living cells and genetic material. The atmosphere absorbs most of it high above the surface. By the time sunlight reaches you, the most dangerous parts have already been removed. Second, the atmosphere moves heat around the planet. Winds carry warm air from the equator toward the cold poles. Cold air moves back in the other direction. This prevents the middle of the planet from becoming impossibly hot and the poles from dropping to temperatures nothing could survive. The gas mixture inside the atmosphere is also critically important. Nitrogen makes up the majority and keeps the system stable. Oxygen allows complex organisms to generate the energy they need to survive. Carbon dioxide traps just enough heat to prevent temperatures from dropping too low at night or in cold seasons. What makes this even more remarkable is the loop that sustains it. Oxygen is a highly reactive gas. It normally disappears quickly by bonding with rocks and minerals in the environment. The only reason Earth still has abundant oxygen is because living things constantly replace it. Plants and microscopic organisms absorb carbon dioxide and release oxygen back into the air. Life maintains the atmosphere. The atmosphere sustains life. That loop has been running continuously for billions of years, and it is one of the main reasons Earth still looks the way it does today. Number 7. Earth's magnetic field saves the planet every single day. You cannot see it. You cannot feel it. But Earth's magnetic field is working right now to protect everything alive on this planet. Without it, Earth's surface would likely be a barren, lifeless rock. Every single second, the sun releases streams of charged particles into space. This constant flow is called the solar wind. Those particles carry enormous amounts of energy. If they reached Earth's surface directly, they would slowly strip away the atmosphere and make the surface completely unlivable. Earth's magnetic field acts as a planetary deflector shield. It extends far out into space, well beyond the atmosphere itself. When the solar wind reaches Earth, the magnetic field bends those particles around the planet and sends them streaming off in a different direction. The surface stays protected. This magnetic field is generated deep inside Earth. The planet has a core made mostly of iron. Part of that core is solid, and part is liquid. The liquid iron moves constantly due to heat rising from below. That movement generates a powerful electric current, and that current creates the magnetic field surrounding the planet. For this system to keep working, Earth needs to maintain internal heat for billions of years. Many planets cool down too quickly and lose their magnetic field long before complex life has a chance to develop. Mars is a good example. It lost its magnetic field early, and today its atmosphere is thin, and its surface is exposed to radiation. Earth stayed warm long enough. The magnetic field persisted. Life on the surface could evolve slowly and carefully, protected from the worst radiation the universe had to offer. The field has weakened at times. It has even reversed direction before. But it never disappeared long enough to cause permanent harm. Invisible and silent, protecting everything, every single day. Number 6. Earth's gravity is balanced in a way that feels intentional. Gravity controls almost everything on this planet. It holds the atmosphere in place so it cannot drift into space. It keeps the oceans from evaporating. It shapes the bodies of every creature that has ever lived here. It determines what can fly, what can walk, how tall trees can grow, and how deep roots need to reach. For all of that to work, gravity needs to be a very specific strength. Not too weak, not too strong. Earth sits almost exactly in the middle of the range that allows complex life to exist. If Earth were significantly smaller, its gravity would be weaker. Over millions of years, the solar wind and radiation from the sun would slowly pull the atmosphere away, just as happened on Mars. Without a thick atmosphere, there would be nothing to protect the surface. Liquid water would evaporate or freeze. Life would struggle to survive. If Earth were significantly larger, its gravity would be far stronger. The atmosphere would become heavier and more compressed. Moving around would require enormous amounts of energy. Complex organisms like the ones that walk, swim, and fly on Earth today would likely never have evolved. Earth's gravity also shapes biology in subtle ways most people never consider. Muscles and bones evolved specifically to function under this level of gravitational pull. Your heart generates exactly enough pressure to push blood up to your brain. You can stand upright without buckling. You can grow to a reasonable height without collapsing under your own weight. Rain falls gently enough to fill rivers and nourish plants without destroying them. Oceans hold enormous amounts of water while still allowing light to reach shallow zones where life thrives. Gravity is everywhere, in everything, at every moment, and Earth has exactly the right amount. Number 5. Plate tectonics keep Earth from dying. Earth's surface is broken into large sections called tectonic plates. Those plates are always in motion, slowly, just a few centimeters per year, but constantly moving. They drift apart in some places and collide in others. When they collide, mountains rise. When they separate, new ocean floor forms. When pressure builds at their edges, volcanoes erupt. Most people think of this as purely destructive, but plate tectonics may be one of the main reasons Earth has remained livable for nearly 4 billion years. Without them, the planet would likely have frozen solid or overheated beyond recovery long ago. Here is how it works. Carbon dioxide is a warming gas that helps Earth stay warm enough for liquid water. Volcanoes release carbon dioxide into the atmosphere over time, but carbon dioxide also gets slowly absorbed into rocks and dragged back down into the planet as plates slide beneath each other. This creates a long-term temperature regulation system. When the planet cools too much, volcanic activity pumps warming gases into the atmosphere. When it warms too much, more carbon dioxide gets pulled out and locked underground. The system self-corrects over millions of years. Plate tectonics also act as a delivery system for the nutrients life depends on. Elements like phosphorus and iron are critical for biological processes. Tectonic activity constantly recycles these materials from deep inside the planet and brings them to the surface. Without this recycling, ecosystems would gradually run out of the raw materials they need. And tectonics create environmental diversity. Mountains, ocean trenches, volcanic islands, and coastal plains all exist because the crust never stops moving. More variety in environments means more opportunities for life to adapt and become complex. Active plate tectonics like Earth has may be genuinely rare in the universe. Earth met all the conditions to start them, and has kept them going ever since. Number 4. The moon is quietly holding everything together. Most people think of the moon as something beautiful to look at in the night sky. But the moon is doing something far more important than that. It is actively stabilizing the entire planet. Earth is tilted on its axis. That tilt is what creates seasons. When the northern half of the planet leans toward the sun, it warms up. When it leans away, it cools down. The southern half goes through the opposite pattern at the same time. This seasonal cycle has been remarkably consistent for billions of years, and the reason it stays consistent is the moon. Without the moon, Earth's tilt would not stay stable. It would shift and wobble chaotically over thousands of years, pulled by the gravitational influence of the other large planets. The axis could tilt so far that the poles would sometimes point almost directly at the sun. Climates would change dramatically and rapidly. Ecosystems would be constantly disrupted. Long-term evolution of complex life would become far more difficult. The moon's gravity acts as a stabilizer. It locks Earth's tilt into a narrow, predictable range. Because of that, seasons stay recognizable year after year. Ecosystems stay consistent enough for species to adapt and diversify over millions of generations. The tides the moon creates matter too. Every day, ocean water rises and falls along coastlines around the world. Those tidal flows mix nutrients through the oceans and create dynamic coastal zones where conditions constantly change. Those zones may have played a major role in pushing early marine life to eventually make the leap onto land. The moon itself formed from a catastrophic collision early in Earth's history. A massive object crashed into the young planet. The debris gathered in orbit and slowly became the moon. A violent accident that somehow produced exactly the right partner for life. Number 3. Earth's chemistry is unusually friendly to complexity. Life is not magic, it is chemistry. Everything alive is built from atoms bonded into molecules, and molecules assembled into increasingly complex structures. For that process to work, you need the right elements, in the right forms, in the right environment, with enough energy to drive it forward. Earth has all of that. The most important element for life is carbon. Carbon forms strong chemical bonds with many other elements and can link together with itself in long chains and branching shapes. That flexibility allows carbon to serve as the backbone of an enormous variety of molecules. Proteins, fats, sugars, and DNA are all built on carbon frameworks. No other element creates the same level of molecular diversity under conditions like those on Earth. And on Earth, carbon is not rare at all. It exists in the air, dissolved in the oceans, locked into rocks, and inside every living thing. The other elements life depends on are also easy to find here. Hydrogen, oxygen, nitrogen, phosphorus, and sulfur are all widely available and capable of combining naturally to form the building blocks of biology. Earth's temperature range makes everything easier. It is warm enough for molecules to move freely and react with each other. But it is not so hot that complex molecules fall apart before they can do anything useful. That temperature window is narrow, and Earth sits comfortably inside it. Water brings everything together by acting as a solvent. It keeps molecules dissolved and in motion, allowing them to meet, interact, and form new structures continuously. The ingredients for life exist in many places across the universe. But the specific environment that allows those ingredients to build a living organism is something far rarer. Earth has that environment, in ways that feel almost deliberate. Number 2. Earth had time, stability, and second chances. There is one ingredient for life that almost never gets talked about. Not water, not oxygen, not carbon. Time. Building life from scratch takes an almost unimaginable span of time. The first simple living things appeared on Earth roughly 3.5 billion years ago. From those first tiny organisms to the complex creatures alive today took billions of years of gradual change, extinction, recovery, and adaptation. That process cannot be rushed, and it cannot survive if the environment keeps catastrophically resetting. Earth gave life both things it needed: time and enough stability to use it. The early Earth was genuinely violent. In its first several hundred million years, the planet was bombarded by asteroids, erupted constantly with volcanic activity, and had an atmosphere toxic to almost everything alive today. But that chaotic phase eventually ended. The bombardment slowed, temperatures stabilized, and life, which had already begun experimenting in sheltered corners of that violent early world, had room to grow. Even after that early period, disasters kept happening. Mass extinctions wiped out enormous percentages of all species multiple times throughout Earth's history. But these events were spaced far enough apart that life always had time to recover. And after each recovery, surviving species diversified into new forms, filling the empty niches left behind. What makes this truly remarkable is how many times Earth came close to permanent failure, but pulled back. The oceans nearly boiled away during extreme warming events, but did not. The atmosphere was damaged and rebuilt, but never collapsed permanently. The magnetic field weakened at various points, but never disappeared long enough to cause irreversible damage. Every time Earth approached the point of no return, something brought it back. Time is one of the rarest gifts in the universe. Earth had it, and life used every second. Number 1. The more we learn, the less Earth feels like an accident. Look at what we have covered. Earth sits in the precise middle of the habitable zone around a calm, long-lived star. Its orbit is nearly circular. It holds liquid water across most of its surface and has kept it liquid for billions of years. Its atmosphere filters radiation and maintains exactly the right gas mixture to support complex life. A magnetic field deflects dangerous solar particles before they can strip the atmosphere. Gravity is strong enough to hold everything in place, but gentle enough that complex organisms can breathe and grow. Plate tectonics recycle the nutrients ecosystems depend on. The moon stabilizes the planet's tilt. Earth's chemistry is ideally suited to building complex biological molecules. And the planet has stayed stable long enough for evolution to move from single cells all the way to intelligence. Any one of these factors alone might be called luck. 2 or 3 might still be explained as coincidence. But all 10 working together, each one supporting and reinforcing the others? Water regulates climate. The atmosphere protects the water. The magnetic field protects the atmosphere. Plate tectonics stabilize long-term temperature. The moon keeps the axis steady so seasons stay predictable. Remove any one of these, and the whole system weakens. Remove several, and it collapses entirely. Scientists have identified thousands of planets outside our solar system. Most are too hot, too cold, too chaotic, or too exposed. A small number have some of the right conditions. Almost none appear to have all of them at the same time. Earth is not perfect, but it is consistently good in every single category that matters. And that might make it one of the most unusual and remarkable places in the entire observable universe.